Hello everyone. Let us see next point. In earlier lecture, we have seen the Fourier integral, Fourier sine integral, Fourier cosine integral, and the examples depend on this formulae. Now let us see the Fourier integral theorem. The statement of the theorem is if fx and f dash x, that means fx and its derivative, are piecewise continuous function on every finite interval, and if this integration minus infinity to infinity mod of fx, mod means positive value of fx dx, is less than infinity, these are the assumption of the theorem, then statement of the Fourier integral theorem is fx is equal to 1 upon pi integration 0 to infinity double integration minus infinity to infinity f of t cos lambda t minus x dt d lambda at the point x where f is a continuous full stop. If x is point of discontinuity of fx, if suppose x is a point where fx has discontinuity, then above integral converges to the average value of the function, that is half f of x plus f of x minus, that means the right hand side and left hand side limit of the function, the average value 1 by 2 into this addition of the limits. Okay, this is a statement of Fourier integral theorem. It can be asked for 2 marks in the sub question of any question. They can ask for state Fourier integral theorem as it is. Okay, now let us start the main point of this chapter. Chapter name is Fourier transform. Now till this lecture we have seen Fourier integral. Now we are going to see the Fourier transform, actual main point of this chapter. Fourier transform consists of 3 points, that is Fourier transform, Fourier sine transform, and Fourier cosine transform. Earlier it was Fourier integral. Okay, remember in the examples these two words, Fourier integral is different, Fourier transform is different. Okay, for Fourier integral you have to use earlier formulas. Now Fourier transform you have to use these formulas afterwards. Okay, let us see the formula first. Fourier transform of any function fx is given by f of s. Like for example, if Laplace transform of f of t, how we write it as L of ft. That means Laplace transform of f of t. Sometimes we call it as phi of s, because answer for f of t Laplace is in terms of s. That's why both the notations are same. L of ft means phi of s. Like that only. Fourier transform of f of x is nothing but, sometimes we can use f of fx. It is a Fourier transform of fx, and in short we can write it as capital F of s. Okay, therefore Fourier transform of fx is given by capital F of s is equal to integration minus infinity to infinity fx e raised to I sx dx. Okay, this is the main Fourier transform formula. And Fourier inverse Fourier transform formula, in some examples we have given the sub questions depend on the inverse Fourier transform formula. They are majorly evaluation of integrations. For that we are going to use inverse Fourier transform. Okay, then inverse Fourier transform is given by this formula fx is equal to 1 upon 2 pi integration minus infinity to plus infinity f of s. This is small fx and this is capital F of s e raised to minus I sx dx. In these two formulas, okay, again here x is there, here also should be x, here yes, here also yes, remember that rule. Now just interchange this inverse for writing the inverse Fourier transform formula. Just interchange fx here and f of s inside, and outside of this is 1 upon 2 pi, and here minus is there. Okay, and this variable change as it is. These are the Fourier transform, inverse Fourier transform formula. Now next is Fourier sine transform formula. Fourier sine transform of fx is given by f s means this s is for sine and this s is our variable. That's why f of s means Fourier sine transform of function is given by 0 to infinity f of x sine sx dx. Obviously this variable is this variable same, and inverse of this inverse Fourier sine transform is given by, just replace, interchange this f of x here, f of s inside, outside 2 by pi, and here as it is, and obviously variable it is yes, that's why it is yes here. Okay, now Fourier cosine transform formulas are given by f of cs. fcs means Fourier, this is cos or cosine of yes is a variable, is equal to, difference between these two formulas is just replace sine by cos. Okay, and inverse Fourier cosine transform is given by, what is the difference between this and this, just replace sine by cos, and yes by fcs. This is called inverse Fourier cosine transform. Okay, now let us see some notes. Okay, first note, sin x and cos x formulas. These are the normal trigonometry formulae. We know one hyperbolic function, sin hyperbolic x e raised to x minus e raised to minus x upon 2. Okay, these are the normal angles or normal trigonometry function. Sin x, this is the basic definition of sin x, that is e raised to ix minus e raised to minus ix upon 2I, while cos x is equal to e raised to ix plus e raised to minus ix upon only 2. For sin I is there in the denominator, for cos only 2 is there. Okay, again e raised to ix is nothing but cos x plus I sin x. This is a formula of e raised to ix. Now again, even and odd function, suppose here if f of minus x is equal to f of x, then such function is called even function, and if f of minus x is equal to minus fx, then such functions are called odd functions. For example, suppose fx is equal to sin x is the one function. Okay, then replace x by minus x everywhere, we get sine of minus x. What it becomes? So no, sine of minus theta is minus sine theta. This is equal to minus as it is. What is sin x? Is our original function, right? That means f of minus x becomes minus fx. That's why such type of examples are called odd functions, where suppose fx is x square plus cos x, suppose, for example. Okay, then f of minus x becomes, replace everywhere x by minus x. Okay, we know minus square is again plus square, and cos of minus theta is plus cos theta, which is our original function fx. That's why in such example where f of minus x become f of x, such examples are called, such functions are called even functions. Okay, this is the basic definition of even and odd functions. And here, even into even functions and odd into odd functions becomes even functions. It's like positive and negative multiplication. Positive into positive becomes positive, negative into negative becomes again positive. That's why even into even becomes even, odd into odd again even. And if any one of the sign becomes minus, suppose minus into plus becomes minus, that's why odd into even becomes odd, or even into odd becomes again odd. This is the regarding even and odd functions. One more result is there regarding integration of even and odd functions. Suppose this is the integration minus infinity to infinity fx dx. This integration is split into, suppose this is minus infinity to infinity, middle point of this number line is 0 obviously. That's why this integration becomes 2 times 0 to infinity. Minus infinity to infinity becomes 2 times 0 to infinity fx dx when fx is even, and it is 0, value of integration becomes 0 if this function is odd. Okay, these are the results we are going to use. Let us see now the examples depend on the Fourier transform. Okay. Find Fourier transform of fx is equal to, this function is given in the interval format. 1 is 1 when mod x less than 1 and 0 when mod x greater than 1. Okay. Hence evaluate this integration 0 to infinity sin x upon x dx. What is there are two questions. First we have to find out Fourier transform of this function. Then whatever the answer, depend on that we have to evaluate this integration. Okay. And generally for Fourier transform examples or Fourier sine and cosine transform examples, hence part where hence evaluate the integrations parts come, then we have to use the inverse Fourier transform formula. Okay, remember that shortcut. Now Fourier transform of fx, we have to write down the first formula, is given by f of s is equal to in minus infinity to infinity fx e raised to I sx, this is e raised to plus I sx dx. Okay, where function is given in the form of this. Now mod x is less than 1 means this is the value. Mod x is less than 1 means x is lies between minus 1 to 1. Remember that. Okay, mod x value is less than any number means that number, that x is lies between minus 1 to plus 1. Okay, this is the function value 1 in this interval. And mod x greater than 1 means apart from minus 1 to 1, that means minus 1, this is the number line infinity to infinity, minus infinity to plus infinity, this is 0, this is 1, this is minus 1. Okay, in between minus 1 to 1 function value is 1, and rest of the all terms, rest of the all values become 0. That means mod x greater than 1 or x is lies between 1 to infinity and x is minus 1 to minus infinity to minus 1. Those values are 0. Okay, now this function's value we have to put in the integration. Integration becomes minus infinity to infinity split into 3 integrations, where 2 integrations are 0. That's why we are not writing here 2 integrations. Just you can write plus 0 or you can skip that. Only one integration remains, that is minus 1 to 1. Okay, and in minus 1 to 1 function value is 1, e raised to I sx as it is dx. 1 into anything is e raised to I sx, integration is e raised to I sx upon derivative of this indice. I is a constant and integration with respect to x, that is s is also constant. That's why constant is is, we have to divide derivative of indice, and limits are minus 1 to 1. Now before putting limits, just take out the constant. What are the constant? 1 upon is the constant. We are putting the value of limits in the x only. Now ultimately write down the limit, upper limit first. 1 here we get e raised to is minus lower limit e raised to minus is, x value minus 1. Okay, now if you observe this is the sine formula. We just need divided by 2I. Okay, that's why 2 is not there, just multiply and divide by 2, and I is already there, take inside. That's why answer is 2 upon, it is originally yes, e raised to is minus e raised to minus is upon 2I, and this value is sine this angle yes. Okay, this is a formula, basic formula. That's why Fourier transform is given. Answer is f of s is, just make the box everywhere for your final answers. Okay, f of s is equal to 2 upon s sin s. This is a one question complete here. Hence evaluate question we can derive it from inverse Fourier transform. If you use here Fourier transform, next sub question can be solved by inverse Fourier transform. If you use Fourier sine transform, next question will be solved by inverse Fourier sine transform. If you use Fourier cosine transform to find out the cosine functions cosine transform, then next evaluate questions will be solved by using inverse Fourier cosine transform. Okay, remember that rule. Now by inverse Fourier transform is given by f of x is equal to 1 upon 2 pi. These are the formulas, minus infinity to plus infinity f of s e raised to minus sx dx. Now put the value of f of s, which we already calculated earlier, that is 2 upon s sin s e raised to minus isx ds. Okay, That's why now take 2 outside of the integration is with respect to, now we have to solve this integration. Integration is with respect to s, that's why except s everything is constant. As of now, take 2 gets cancelled, 1 upon pi integration minus nu to infinity sine s e raised to minus isx upon s. Now remember such type of example, if I e raised to minus isx or e raised to plus ixs is there, we have to write down the formula of e raised to minus isx here, because this integration can't be solved by using regular method. What is e raised to ix? Cos x plus I sin x. What is e raised to minus ix is same. Just replace cos x minus I sin x. Okay. If it is plus, middle sign is plus. If it is minus, middle sign is minus. Therefore, e raised to minus ixx becomes this rest of the terms as it is cos sx. This is the angle. Coefficient of I is the angle. Cos sx minus, this is minus I sin sx. Angle of cos and sine must be same. Bracket complete into ds as it is. Now take this term inside the bracket and separate out the integration. We get 1 upon pi, first integration, put the square bracket, sin s cos sx upon s minus this I is a constant term, take outside of the integration, second integration, in minus infinity to infinity, sin s into sin sx into upon s, that means 1 upon s. Okay. Now here in this step we are going to use this formula. Okay. Minus infinity to infinity fx dx is 2 times 0 to infinity, middle point of this interval and upper limit as it is. If function even and odd, that means we have to going to find whether the functions are even or odd. See, here 3 functions are there. Okay, 1 upon s, sin s, cos s. If you want to decide whether the function even and odd, just replace s by minus s everywhere. If the functions remains as it is, that means that function is a even function. If minus comes out of the function, then that function is a odd function. For example, here cos of minus, what is our variable? Yes. Instead of yes, if you put minus yes here, what it becomes? So cos of minus sx, and we know cos of minus theta is plus cos theta. That's why this function is an even function. Okay. Now sine of minus s is again a minus sin s, that's why it is odd function. And again 1 upon s, if you put minus s here, it becomes minus as it is there. Okay, that way it is odd function. That means odd into even, 3 functions are there. For that odd into odd function we know even function, and even into this even becomes final even function. That means this integration is a consist of even function. Okay. Now this, what is the difference between this and this? Instead of cos, this is only sine. Rest of the terms as it is. Now odd into odd. 3 times minus becomes minus, like multiplication. That's why this integration function is odd function. That's why if this is even function, then according to this formula, this integration becomes 2 times middle number of this interval 0 to infinity. Like that, what is the middle number of minus infinity to infinity? 0. That's why this integration becomes 2 times, and this integration becomes 0 because it is odd. Understand? You have to write every rule here. Okay, right here, because since integration minus infinity to infinity function fx dx is equal to 2 times integration 0 to infinity fx dx if fx is even, and it is 0 if fx is odd. Okay, write down this reason here. That's why This first integration only remains 2 times 0 to infinity. Rest of the terms as it is. This becomes 0. No need to write 0. Or can be right here as 0. Okay. Therefore, fx is 2 upon pi integration 0 to 2 times 0 to infinity sin s cos sx upon s ds. Okay. And plus next integration is 0. Now, our this is our result. Now we have to find? See, we have to find this integration 0 to infinity sin x upon x dx, and we get this integration 0 to infinity sin x upon s is only there. To get only sin s upon s, you need value of x such that cos sx becomes 1. Understand? Because in this integration variable is s. Okay, apart from this yes, this integration contains x. That's why x is a constant here, and we can write down, we can put the value of x such that cos sx becomes 1, and we know for what value of cos angle the cos is 1, we know that is 0, right? Cos 0 is 0 only, right? That's why put x is equal to 0 in this function. What we get? Put x is equal to 0, what we get? Here f of 0, our LHS side must be f of 0. You can write down this also, where this integration is equal to function is given in the example as it is here. Okay, now here we have to put x is equal to 0 everywhere. Okay, now here becomes 2 upon pi integration as it is. Here only x cos 0 becomes 1 sin s upon s ds as it is. And here in which interval 0 occurs? In first interval, because mod x less than 1 means minus 1 less than x less than 1. In minus 1 to 1 there is only 0. That's why put x is equal to 0 here in first interval. Answer is 1. That's why RHS side is 1. Therefore, take pi by 2 on that side. We get the integration 0 to infinity sin s upon s ds is equal to 2 pi upon 2. But our example contains x variable, dummy variable. That's why replace, put x is equal to x, that is a dummy variable. We get this answer. Okay. Integration 0 to infinity sin x upon x becomes pi by 2. Now consider next example. Find Fourier transform of fx, where fx is given in the form of interval for mod x less than 1 means minus 1 less than x less than 1. Function value is 1 minus x square, and it is 0 otherwise for rest of the interval, and hence evaluate this integration. First let us find out the Fourier transform of this function. It is same as earlier example. Fourier transform of fx is given by f of s integration minus infinity to plus infinity fx e raised to isx dx. Now put the value of function here. We know function is given in the form of interval. Minus 1 to 1 is the only limit here, because fx is 1 minus x square for mod x less than 1 means mod x minus 1 less than x less than 1, and it is 0 otherwise. Otherwise means for rest of the all intervals. Therefore, the function lies between minus 1 to 1. Integration becomes minus 1 to 1. Function value is 1 minus x square e raised to isx dx. Again same procedure is there. When e raised to isx is there, we have to convert this e raised to isx into cos x plus I sin sx formula. Okay. Cos sx. Sx is the angle of trigonometry, sine and cos, which is coefficient of I here. Okay. This is the first formula of e raised to ix. That is cos sx plus I sin sx dx. This rest of the terms as it is. Now again we have to split this integration into two. That means, see, here take this bracket inside of this bracket, and take integrations, separate the integration, and ultimately take this I is a constant outside of the integration. Like earlier example, what we get, integration minus infinity to plus infinity, minus 1 to 1 minus x square cos sx dx, first integration, and plus I into minus 1 to 1 minus x square sin sx dx, a second integration. Now again we have to make sure the integrand is even or odd, depend on the functions, because the limits are minus infinity to infinity. That is also valid for minus 1 to 1, minus 2 to 2, minus a to a, any number. Okay, that's why, see, here in this first integration, these two brackets are there, two functions are there. This function is always, of course, even function, because if you replace x by minus x, it comes to same. That means it is a even function, and obviously cos is also even function. That's why even into even becomes even. Here this is even function and sine is odd function. That's why even into odd becomes odd. That's why this integration becomes 0. 0 you can no need to write, and this integration becomes 2 times. What is the middle value of minus 1 to 1? 0. 0 to upper limit 1 as it is, this integration as it is. Okay, this integration becomes 0. You have to write here a reason. Okay, formula write down in the assignment. Now this is the very easiest integration, u into v. This is algebraic function, this is trigonometry function. That's why you can solve it by part rule or u into v rule. This is u obviously by Liet rule. What is Liet rule? Okay, L is logarithmic, I is inverse function, A is arithmetic, this is arithmetic, T is trigonometry, this is trigonometry, and E is a exponential. That's why A come first. That's why this is u, this is v. 2 as it is, u into integration of cos, that is sin sx upon s. Integration is with respect to x. That's why s is a constant. That's why divided by s is there. Angles derivative minus, second term minus, by part rules second term is minus. This function's derivative here, this function's derivative is 1 0, 1 derivative is 0, minus as it is x square derivative is 2x, minus 2x, and this function's integration here. In this function's integration, s is a constant, that is as it is, and cos sx derivative is minus cos sx divided by sx derivative should be divided, that is yes, and already s is there. That's why that s multiplied together to get s square in the denominator. Okay, now plus, next term will be, this is plus, this is minus, this is again plus, alternating plus minus terms are there. This function's derivative here, minus 2x derivative is plus minus 2, and this function's integration is here, minus as it is 1 upon s square is also as it is, and cos sx integration is sin sx upon s, and already s square is there. That's why it becomes s cube here. Now next term of by part is minus, minus 2's derivative is 0. That's why by part rule ends here, that series ends here. Limits are 0 to 1 as it is. Okay, now we have to put limits 1, we have to put in x. Here 1 minus 1 becomes 0. Here, okay, before that obviously we do one thing, just remove the all brackets. 1 minus x square, this as it is, minus 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 3 times minus, it becomes 1 time minus 2x upon this as it is, and this minus minus becomes plus. Okay, simplify before putting the limits. Okay, now put the limit 1 in x, we get this 0. This becomes 2 minus 2 into cos s into 1, that is cos s upon s square, and this is plus 2 sin s upon s cube. This is upper limit. Okay, now minus lower limit 0 we have to put in x, sin 0 0, sin 0 0. Again here multiplication with respect to 0 becomes 0. Lower limit whole terms becomes 0. Okay, now therefore here lower limit is 0, upper limit is this. You don't need to write to 0 in next step. take 2 outside of this bracket, multiply with this 2, we get 4, and take minus second term, and positive term take first, write down first. We get sin s upon s cube minus cos s upon s square. Take denominator, from denominator take s cube common, we get 4 upon s cube. Here sin s minus, here only s square, that's why we have to multiply by s cos s. Okay, this is the first answer of this question, our question. Fourier transform of the function. Okay, now we have to evaluate the integration. This is our integration. Okay, now we have to use inverse Fourier transform for that. Now inverse Fourier transform is given by this formula, fx is equal to this. Okay, this is our original formula, where f yes is nothing but our earlier answer. Write down this term as it is here. We get 4 upon s cube, this term as it is, into e raised to isx. You can skip one more step here by directly write down the formula for e raised to minus isx here, cos sx minus I sin sx ds. Okay, now take this 4 outside because it is constant, it becomes 2 upon pi, and separate out this integration at a time. Take this bracket into cos x minus this bracket into sin x, and ultimately I is a constant, take outside, you can take outside. This integration becomes 2 integrations, that's minus infinity to infinity. This already we get outside, sin s minus s cos x upon s cube into cos sx minus, as it is I outside, integration to minus infinity to infinity, this term as it is, into sin sx ds. Okay, now we have to decide whether this all term are even or odd. For that, make this term as this term 1 and second one is this. Okay, split into 2 only. This is 1, this is second. We have to because this term is same here, it is as it is here, that's why we are going to calculate whether this function, bracket function, is even or odd, because rest of the term cos and sine we know they are even or odd. First write down this, you can sin s minus s cos s upon s cube. Okay, this is our function. Now whether we have to decide whether it is odd or even, replace s by minus s everywhere. What we get? Sine of minus s minus, this is again minus s, cos of minus s everywhere, wherever it is, upon minus s, rest of the terms square, cube, multiplication as it is. Now we know sine of minus theta is minus sin s. This minus becomes plus, and cos of minus theta is cos theta, divided by minus s cube becomes 1 minus is there, minus s cube. Okay, now take minus common from the denominator, we get minus sin s, this becomes minus cos s, yes cos s, yes is there, upon this minus s cube. Okay, minus gets cancelled, answer is sin s minus s cos s upon s cube, and this is same as our original function. Okay, that's why what is the function, even or odd, it is even function. Okay, that's why this is even function, this is even function, even into even becomes, this is total even function, first integration is even function, minus this is even, sine is odd, even into odd becomes odd. Okay, that's why this integration, according to the integration formula, this integration formula, if f is odd it is 0, if it is given, it is 2 times. That's why this integration becomes 0, minus I into 0 you can write down as it is, and this integration becomes 2 times. What is the middle value? 0 to infinity. This as it is, 2 times this integration as it is. This is 0. Okay, now 2 to the 4 upon pi integration 0 to infinity sin s minus s cos s upon s cube cos sx ds as it is. This we get as fx by inverse Fourier transform. Okay, now what is our question? See, we have to evaluate this integration. We get this integration and fx. Okay, see, the here dummy variable is x, here dummy variable is, our variable is yes, both are same. See, s cos x, yes cos s, sin x upon s cube x cube s cube, and cos x by 2 dx cos s x only. Okay, that's why which value we have to put here so that it becomes x by 2, 1 by 2, right? Put here in the next step x value on the both side as 1 by 2. We get, put x is equal to here 4 upon pi as it is. Now write down the function value. This integration is equal to fx, and fx is our original function given in the example like this. Okay, that's why in the next step this integration is equal to fx. This is our fx. Okay, mod x is less than 1 means minus 1 less than x less than 1. Okay, and this is otherwise. Now we have to put x is equal to half in the above example. Both the side, what we get, 4 by pi 0 to infinity sin s minus s cos s upon s cube cos x only 1 by 2. That's why it becomes cos s by 2 ds. And on RHS side, we have to put x is equal to half. In which interval? Obviously here. Half this interval is contains only half point. Okay, because this is infinity, this is minus infinity, this is 0, this is 1, this is minus 1. In this interval only half is in between 0 and 1. That's why I put half here in this first interval. We get 1 minus half square. Okay, what is half square? 1 by 4. 1 minus 1 by 4 is 3 by 4. Now take 4 by pi on that side. We get integration this 0 to infinity, rest of the terms as it is, it equal to 4 gets cancelled, 3 and so sorry 4 comes to denominator and pi comes to numerator. We get 3 pi by 16. Okay, now this is our dummy variable yes. Now replace s by x everywhere, dummy variable. Okay, we get 0 to infinity and reverse this term, because see, we get this and we want this. What is the difference between this and this? Just take the reverse term. Yes, cos x terms at the second and sin x at the first term. That's why we have to just reverse this term. And ultimately put the dummy variable also. We get 0 to infinity x cos x, reverse the term, minus sin x upon x cube into cos x by 2 dx. And by taking the reverse term, take minus sign on that side, we get 3 minus 3 pi by 16 is our answer for this integration.